Hello students, welcome to my channel GBS Chem. In this video, I am going to explain colligative properties elevation in boiling point. Please subscribe to my channel, like, share and comment my videos.
Colligative properties are those properties which depend on only number of particles of the solute but not on the nature of the solute. So colligative properties number one, relative lowering of vapor pressure RLVP. Second, elevation in boiling point. Elevation in boiling point. Depression in freezing point. Depression in freezing point. And the fourth one is osmotic pressure. Osmotic pressure. Now let us discuss each and every colligative property. Relative lowering of vapor pressure, I made a separate video previously, so you can go through it and learn well. Now let us discuss the elevation in boiling point. So elevation in boiling point. What is meant by boiling point? Boiling point is the temperature of a pure liquid where the vapor pressure becomes equal to atmospheric pressure. So temperature of a pure liquid, temperature of a liquid where vapor pressure becomes equal to atmospheric pressure. That is the boiling point. So boiling point is nothing but the temperature at which temperature of a liquid where the vapor pressure becomes equal to atmospheric pressure. So boiling point of water 373.15 Kelvin and vapor pressure equal to 1.013 bar at this temperature. This is nothing but atmospheric pressure. So as the vapor pressure becomes equal to atmospheric pressure, the boiling point of water is 373.15 Kelvin. Now let us try to understand this by drawing a graph. This is temperature. This is vapor pressure, and of course this is 373. This is vapor pressure. Now the vapor pressure of a pure liquid. So this is a pure liquid. This is the vapor pressure, and draw a line, vertical line, where it touches the temperature axis. This temperature is 373.15 Kelvin. Now, if we add a non-volatile solute, we know that the presence of non-volatile solute decreases the vapor pressure. How it decreases we discussed already. So, the presence of non-volatile liquid, non-volatile solute in a solvent decreases the vapor pressure. Suppose if we add a solute to this solvent, so this is the curve of the solution. So this solution, the vapor pressure does not reach to the atmospheric pressure. In order to equalize this vapor pressure to the atmospheric pressure, we have to raise the temperature. So the temperature reaches up to here. Therefore, in order to equalize the vapor pressure to atmospheric pressure, we have to we have to raise the temperature. We have to raise the temperature. So in order to equalize the vapor pressure to atmospheric pressure, as non-volatile solute is dissolved in the pure solvent, we have to raise the temperature. So therefore, this is the vapor pressure of the, this is the vapor pressure of a solution. Therefore, temperature increases. So this is nothing but, this difference is nothing but elevation in boiling point. Elevation in boiling point. For example, pure water boils at 373.15. If 1 mole of sucrose is present in 1000 grams of water, then the boiling point increases to 373.52 Kelvin. That means 0.37 Kelvin increased. The boiling point increased by 0.37 Kelvin. So this is nothing but the elevation in the boiling point. So thus we can find the elevation in boiling point by dissolving the, we can find the elevation in boiling point. Now elevation in boiling point is denoted by delta TB. So delta TB equal to TB minus TB naught. What is TB? TB is the boiling point after dissolving the non-volatile solute. So TB is the boiling point of solution. TB naught is the boiling point of pure solvent. Right. Delta TB is proportional to M. M is molality. So delta TB is equal to remove this proportionality, we can write one constant known as KB, where KB is the molal elevation constant, or boiling point elevation constant. Now M equal to molarity. How do we write the molarity formula? Weight of the substance by, that is solute, weight of the solute by molar mass into 1000 by g grams of solvent. So W means weight of the solute. M is the molar mass of a solute. G is the weight of solvent in grams. So these are the usual notation. Now let us write delta TB equal to KB into M. So we write M. In this, delta TB equal to KB into M. M is nothing but weight by molar mass into 1000 by g grams of solvent. Now KB for water is 0.52 Kelvin kilogram per mole. So molar elevation constant is different for different solvents. So for water it is 0.52 Kelvin kilogram per mole. So this is the molar elevation constant. Now let us do some problems based on this elevation and boiling point. Now let us do one problem based on elevation and boiling point. Boiling point of water at 750 millimeter of mercury is 99.63. How much sucrose should be added to 500 grams of water if Kb for water is 0.52 Kelvin kilogram per mole? Now first of all, the solute is sucrose. Sucrose formula C12H22O11. So molar mass. What is the molar mass? Molar mass of sucrose is 12 carbon atoms are there, 12 into 12 plus 22 hydrogen atoms are there, 22 into 1 plus 11 oxygen atoms are there, 11 into 16. So this is 144 plus 22 plus 176. So this is 342 gram per mole. So molar mass of sucrose is 342. Now elevation in boiling point. Elevation in boiling point is, so the problem is how much sucrose should be added to 500 grams of water if the water should be boiled at water should boil at 100 degrees centigrade. So what is the elevation and boiling point? 100 minus previous boiling point is 99.63. So what is the difference? The difference is 0.37 Kelvin kilogram mole minus 1. So this is Kb. Now Kb equal to this is delta Tb. Delta Tb equal to Kb into W by M into 1000 by G grams. 1000 by G grams. What are the usual notation? Tb, delta Tb is elevation in boiling point, that is 0.37, and Kb, molar elevation constant of water, that is 0.52. W is the weight of the sucrose that we have to find. Molar mass of sucrose is 342, and G is the weight of the solvent in grams, that is 500 grams. So this is 0.37 is equal to 0.52 into W by 342 into 1000 by G grams. What is the weight of the solvent? Weight of the solvent is 500 grams. So this is 500. 500 here 2 times, 2 here 171. So weight of the substance is equal to 0.37 into 171 by 0.52. This we can write it as 0.37 into 171 by 52, because in numerator and denominator decimal place is there before two digits, therefore this decimal is removed. Therefore this is nothing but 37 into 171. 37 into 127 is 6227 by 52. So if we divide this becomes 121.67 grams. So this much amount of sucrose should be added to 500 grams of water. 500 grams of water, so that the boiling point becomes 100 degrees centigrade. Now let us do one more problem. 18 grams of glucose formula is C6H12O6 is dissolved in 1 kilogram of water in a saucepan. So to make the saucepan, 18 grams of glucose is dissolved in 1 kilogram of water. At what temperature water will boil? If Kb for water is 0.52 kilogram per mole. So first of all, the solute is solute is glucose C6H12O6. So what is the molar mass? Molar mass of glucose is equal to 180 gram per mole. So delta TB is equal to KB into W by M into 1000 by G grams. So here water given is 1 kilogram. 1 kilogram is 1000 grams. So equal to KB. KB is 0.52. It is given already into 18 by 180 into 1000 by weight mass of the water is 1000. So 1000 get cancelled. 18 goes one time, 10 times here. Therefore this is nothing but 0.052. Therefore water boils at what is the boiling point of pure water? 373.15 plus elevation boiling point 0.052. Therefore this is 373.2. This is 5 plus 5 10, 1 2 here. So water boils at as glucose is dissolved in water boils at 373.202 Kelvin.